We're going to explain how to handle OnChange delays in ReactJS while typing. 1. Imagine you're building a search bar. Every time a user types a character, the OnChange event fires, potentially triggering an API call. This can be inefficient, especially with slow connections or expensive API requests. 2. The solution is to debounce or throttle the OnChange handler. Debouncing waits until a certain time has passed since the last keystroke before triggering the action. This prevents multiple API calls if the user types rapidly. 3. One popular way to debounce is using the Lodash library's debounce function. Import it, then wrap your API call within debounce. The first argument is the function to debounce. The second is the delay in milliseconds, e.g. 300 millims. 4. This means the API call will only happen 300 milliseconds after the user stops typing. 5. Here's how that might look in your React component. Const handle search change equal to debounce your API call here is 300. 6. Then, attach this debounced function to your input's OnChange event. Input type text OnChange, handle search change. 7. Throttling, on the other hand, limits the rate at which the function is called, regardless of how frequently the event fires. 8. It's useful when you need to ensure a maximum number of calls per time unit, even if the user types continuously. 9. Lodash also offers a throttle function, used similarly to debounce. 10. You could use character throttle handle search change 1000 to limit calls to once per second. 11. Remember to choose between debouncing and throttling based on your specific needs. Debouncing is better for preventing multiple calls triggered by rapid input, while throttling is better for limiting the rate of calls even with continuous input. 12. Beyond Lodash, you can implement debouncing and throttling yourself using setTimeout and clearTimeout for more control or to avoid adding external dependencies. 13. Implementing your own debounce function might involve storing a timeout ID, clearing it on every keystroke, and setting a new timeout to execute the API call after the delay. 14. Consider the user experience. Too long a delay might frustrate users, while too short a delay could lead to performance issues. Experiment to find the optimal delay for your application. 15. Finally, always handle potential errors during API calls and provide appropriate feedback to the user. This might involve displaying a loading indicator while the API request is in progress, or an error message if the request